Antarctica is often described as the most silent place on Earth, a continent locked beneath kilometers of ice, untouched by cities, roads, or permanent human settlement. From orbit, it appears motionless, almost inert, a frozen boundary at the edge of the known world. And yet, beneath this stillness, signals have been detected that challenge that assumption. Modern Antarctic research stations are equipped with instruments designed to listen, not to look. Radar systems penetrate deep ice layers. Seismic sensors record minute vibrations. Electromagnetic receivers monitor background noise that most environments drown out. Antarctica, with its isolation and stability, offers a rare opportunity, a place where interference is minimal and anomalies are difficult to dismiss. It was within this environment that researchers began noticing something unusual. The signal did not arrive suddenly. It was not accompanied by alarms or dramatic spikes. Instead, it appeared as a repeating pattern, subtle, consistent, and persistent. At first, it blended into background data, indistinguishable from system noise. Only after extended observation did its regularity become apparent. Unlike natural electromagnetic disturbances, the signal did not fluctuate with weather, solar activity, or seasonal change. It repeated at fixed intervals. It did not weaken over time. It did not migrate. It behaved less like an environmental phenomenon and more like a stable source. As analysts traced the signal's origin, attention shifted downward, far beneath the ice. Radar imaging revealed an anomalous structure embedded deep below the surface. Not a cavity, not a liquid pocket, but a solid form with sharply defined boundaries. What made this discovery unsettling was not its presence, but its behavior. The object reflected radar waves in a manner inconsistent with ice, rock, or sediment. Its response was uniform, suggesting a single material composition rather than layered geology. In cross-section, its shape appeared smooth and continuous, lacking the fractures and irregularities typical of natural formations. Even more concerning was its depth. The structure lay beneath ice layers that predate recorded human history. Ice that accumulated gradually over tens of thousands of years. Ice that did not form quickly, but slowly sealed whatever existed beneath it. Whatever this object was, it did not arrive recently. It was already there when Antarctica froze. At this stage, no physical access was possible. Drilling through kilometers of ice carries extreme risk, and no mission was authorized to attempt direct contact. Everything known came from indirect observation, signals, reflections, and models. Yet the data agreed on one point: the object was massive. Far larger than any known subglacial structure. Too uniform to be geological, too stable to be transient, and too deeply buried to be explained by modern activity. The Antarctic ice is often seen as a barrier, a natural wall separating humanity from what lies beneath. In this case, it may also be a preservative, locking something in place far longer than it was ever meant to be observed. The signal continues. It does not respond. It does not change. It simply persists. And that persistence raises a question that no model has yet answered. What exists beneath the ice that does not belong to it? Once the anomaly was isolated from background noise, attention shifted to its most unsettling characteristic: consistency. Natural signals are rarely stable. They drift, decay, intensify, or disappear as conditions change. This signal did none of those things. Hour after hour, day after day, it repeated with the same interval, the same intensity, and the same spectral profile. Researchers began by testing the most obvious explanations. Solar activity was ruled out first. The signal did not correlate with solar flares, geomagnetic storms, or known space weather cycles. Atmospheric interference was eliminated next. Antarctica's dry, stable air minimizes distortion, and parallel instruments placed kilometers apart detected the same pattern simultaneously. Instrument error was considered, systems were recalibrated, redundant sensors were activated, independent stations compared data. The signal remained unchanged across platforms and distances. It did not originate from the equipment. It passed through it. Frequency analysis revealed something more troubling. The signal occupied a narrow band, sharply defined, without the broad scatter typical of environmental noise. Its edges were clean, its timing precise. There was no gradual onset or fade out, only repetition. As if the signal were being maintained rather than generated spontaneously. When researchers attempted to classify it, existing categories failed. It did not behave like seismic resonance. It did not match known electromagnetic emissions from ice movement or bedrock stress. It showed no response to temperature shifts, pressure changes, or seasonal ice flow, even during storms that distorted other readings. The signal remained steady. Mapping the signal back to its source revealed a clear point of origin, the subsurface anomaly. The pulses did not originate from the surrounding ice, nor from the rock beneath. They traced consistently to the same internal region of the structure detected by radar. This raised an uncomfortable implication. The signal was not a side effect of the object. It was being produced by it. At this stage, speculation was deliberately restrained. No conclusions were drawn about intent, intelligence, or design. The focus remained on behavior. Whatever lay beneath the ice was acting as a stable emitter, maintaining output without observable variation. Equally significant was what the signal did not do. It did not accelerate. It did not respond to monitoring. It did not interact with surface systems beyond passive detection. There was no escalation, no modulation, no attempt at communication. The signal existed in isolation, indifferent to observation. This lack of reaction complicated interpretation. If the signal were a natural process, it was unlike any documented before. If it were artificial, it showed no interest in being noticed. In either case, it defied expectation. The Antarctic environment is unforgiving. Extreme cold, immense pressure, and long-term isolation eliminate most sources of sustained activity. Anything capable of producing a stable signal under such conditions would require exceptional durability, or an origin far older than the ice surrounding it. As data accumulated, one conclusion became unavoidable. The signal was not a temporary anomaly. It was not fading. It was not weakening. It had likely existed long before it was detected. The question was no longer whether the signal was real. The question was how long it had been there, waiting beneath the ice, unnoticed. As attention shifted from the signal itself to the structure producing it, imaging became the focus. Ground-penetrating radar and deep ice scanning are not designed to produce clear pictures. They translate reflections into data, data into models, and models into approximations. What emerged from this process was not a photograph, but a shape, and the shape raised immediate concerns. Natural formations beneath ice rarely present clean boundaries. Rock fractures, ice distorts, pressure deforms. Over time, everything underground becomes irregular. The anomaly beneath Antarctica did not follow this rule. Its outline appeared smooth, continuous, and sharply defined against the surrounding ice and bedrock. Repeated scans confirmed the same geometry. The structure did not change with angle or depth. Cross-sections revealed consistent curvature rather than jagged profiles. There were no signs of collapse, erosion, or sediment intrusion. Whatever the object was, it resisted deformation in an environment where even mountains slowly bend. Scale added another layer of difficulty. As models refined, the estimated size of the structure expanded. It was not small. It was not localized. It extended across a footprint far larger than any known subglacial feature. Yet it remained singular, one continuous mass rather than a cluster of formations. Comparisons were inevitable. Subglacial lakes, though large, show fluid signatures and irregular edges. Volcanic intrusions appear bulbous and fractured, with thermal gradients radiating outward. Meteorite impacts produce chaotic debris fields and shock patterns. The Antarctic anomaly matched none of these profiles. Even more telling was symmetry. Symmetry is rare in geology. It can occur, but not persistently across multiple dimensions. The structure beneath the ice exhibited proportional balance. Its dimensions aligned too evenly. Its surfaces reflected radar uniformly, suggesting a consistent material rather than layered deposits. Material response reinforced this concern. Radar reflections indicated a density and conductivity inconsistent with ice, sediment, or common rock. The signal return was strong and predictable, more similar to metallic reflection than mineral scatter. Yet no known metallic formation of this scale exists naturally beneath Earth's crust, especially not one isolated beneath kilometers of ice. At this point, researchers began using exclusion rather than identification. They did not claim to know what the object was. They focused on what it could not be. It could not be a void. It could not be liquid. It could not be a fractured geological body. Each eliminated category narrowed the field without providing clarity. What made this process uncomfortable was its direction. With every natural explanation removed, the remaining possibilities became harder to frame scientifically. Not impossible, but unsupported by precedent. Importantly, no signs of movement were detected. The structure did not shift with ice flow. It did not vibrate with seismic activity. It did not respond to external stress. It behaved as if anchored, either extremely massive or intentionally positioned. The ice above it told its own story. Layer after layer had formed undisturbed. No melting, no refreezing, no structural disruption. This indicated that the object had been present before the ice accumulated, not introduced after. By the end of this phase of analysis, consensus formed around a single statement, carefully worded and deliberately cautious. The structure beneath the Antarctic ice does not behave like a natural formation. And once that threshold was crossed, the investigation could no longer remain purely descriptive. Because geometry, when it appears where it should not, demands explanation. As the geometry of the buried structure became increasingly difficult to dismiss, attention shifted toward its material properties. Radar does more than outline shapes. It reveals how a surface responds, how energy is absorbed, scattered, or returned. In natural environments, that response is rarely uniform. Ice diffuses signals, rock fractures them, sediment weakens them unevenly. What researchers observed beneath the Antarctic ice did not match any of these behaviors. The anomaly reflected radar waves with unusual strength and consistency. Across multiple frequencies, the return signal remained sharp, stable, and coherent. There was no evidence of layered absorption, no gradual loss of intensity with depth. Instead, the signal behaved as if it were encountering a solid, continuous surface, one that returned energy efficiently rather than dispersing it. This behavior immediately ruled out several possibilities. Ice, even under extreme pressure, does not reflect radar in such a focused manner. Rock formations produce complex scatter patterns due to cracks, mineral variation, and internal stress. Even dense crystalline structures introduce irregularities. The Antarctic anomaly did not. Its response was clean, predictable, and repeatable. Conductivity measurements added another layer of concern. Subsurface materials typically show variation as temperature, pressure, and composition change. The structure beneath the ice did not. Its conductive response remained uniform across its visible surface. That level of consistency is characteristic of engineered materials, not geological ones. Metallic reflection became an unavoidable comparison. Metals, particularly large continuous metallic bodies, reflect electromagnetic waves with precision. They do not blur edges. They do not fragment returns. When radar encounters metal, it knows. The Antarctic structure behaved accordingly, yet the implications were troubling. No known natural process produces a metallic mass of that size, with that degree of uniformity, and places it beneath kilometers of ice without associated debris or thermal signatures. Thermal analysis deepened the puzzle. Metals conduct heat efficiently, yet no heat anomaly was detected above the structure. Temperatures within the ice followed expected gradients. There was no melting, no distortion, no indication of internal heat generation. If the object was metallic, it was inert or designed to be. Researchers were careful not to overstate conclusions. No one labeled the object definitively. Reports used restrained language, highly reflective, materially anomalous, non-geological, but internally, the implications were understood. Every material property pointed away from stone and toward something manufactured, or at least structured in ways not explained by Earth's geology. Even more unsettling was durability. Under immense pressure, most materials deform. Ice flows, rock fractures. The anomaly showed no such behavior. It maintained structural integrity despite forces that reshape mountains over time. This suggested either extraordinary mass, extraordinary strength, or both. At this stage, the investigation reached a critical shift. The question was no longer whether the structure was unusual. That had been established. The question became whether existing scientific frameworks were sufficient to describe it. Material analysis does not infer purpose. It does not assign intent. It only asks how something behaves when energy interacts with it. And by every measurable standard, the object beneath the Antarctic ice behaved less like a natural formation and more like a constructed surface. Whatever it was made of, it was not fragile. And whatever it was not meant to disappear. Once the structure's material properties were examined, attention turned to a question even more difficult to confront: time. Antarctica did not always look as it does today. Beneath its ice lies a geological record that preserves climate, atmosphere, and environmental change across immense spans of history. By studying that record, researchers could begin to estimate when the object became buried. Ice core data offered the first clues. Layer by layer, compressed snow reveals a timeline stretching back hundreds of thousands of years. Volcanic ash, dust, and trapped air bubbles serve as markers of known events. When analysts compared the depth of the anomaly to these layers, the implication was immediate and unsettling. The structure lay beneath ice that formed long before human civilization emerged. This meant the object did not arrive after Antarctica froze. It was already there when the ice began to accumulate. Glaciation in Antarctica did not occur suddenly. It unfolded over millions of years as the continent drifted toward the South Pole and global temperatures declined. Ice advanced gradually, sealing the land beneath it in stages. For the structure to be embedded at such depth, it would have had to predate this process, or at least exist during its earliest phases. Ice flow models reinforced this conclusion. As glaciers move, they bend and deform around obstacles. Bedrock shows signs of stress. Yet scans revealed that ice layers above the anomaly remained undisturbed. They flowed smoothly over it, suggesting that the structure had been stationary for the entire duration of ice formation. There was no evidence of later intrusion or displacement. Sediment analysis ruled out recent burial. No signs of impact debris, melt channels, or refreezing layers were detected. The ice above the object showed continuity, not disruption. This was not something that fell from the sky or was driven into the ground. It had been enveloped, not embedded. Age estimates became conservative by necessity. Researchers avoided assigning exact numbers. Instead, they used minimum thresholds. Tens of thousands of years was certain. Hundreds of thousands were plausible. Millions could not be excluded. At this scale, even cautious language becomes heavy with implication. If the structure existed before Antarctica froze, then it existed in a world radically different from our own. A time when the continent supported forests, rivers, and life. A time when Earth's climate, geography, and ecosystems bore little resemblance to the present. No evidence suggests that humans, or any known technological civilization, operated at such a time. Archaeology offers no support for advanced construction millions of years ago. And yet, the object beneath the ice did not behave like a natural remnant of that ancient world. This placed researchers in an uncomfortable position. The data did not support a modern origin. It did not support a known ancient one. And it did not align with geological processes that could plausibly create such a structure on their own. In science, uncertainty is acceptable. Contradiction is not. When multiple independent lines of evidence converge on the same conclusion, that conclusion must be acknowledged, even if it raises more questions than it answers. The Antarctic ice did not hide the structure by accident. It buried it slowly, patiently, over ages of planetary change. And whatever lies beneath it has endured that change without yielding to time. With age estimates pushing far beyond human history, the question of origin became unavoidable. Scientists approached it carefully, aware that speculation without evidence could derail the entire investigation. Instead of asking what the structure was, They asked a more restrained question: what could it not be? Geological origin was examined first, and ultimately set aside. Known natural processes do not produce large-scale, symmetrical, highly reflective structures composed of uniform material. Even the most extreme geological formations, igneous intrusions, crystalline bodies, or tectonic anomalies, show internal variation, fracture patterns, and thermal signatures. The Antarctic structure showed none of these traits. Its behavior remained internally consistent across every measurable parameter. Meteoric impact was also considered. Large objects have struck Earth throughout its history, leaving behind metallic remnants and shock-altered rock. But impacts leave unmistakable evidence: craters, dispersed debris, altered strata. None of these indicators were present. The ice and bedrock above the anomaly showed no disruption consistent with an impact event. Human construction, even by an unknown ancient civilization, faced insurmountable problems. No archaeological record supports large-scale technological activity millions of years ago. No tools, waste, or transitional structures have been found. And even the most speculative models of lost civilizations cannot reconcile the object's depth, age, and preservation with known human timelines. That left only possibilities that could not be tested with current data. Some researchers cautiously proposed that the structure might be a remnant of a non-geological process no longer active on Earth, something tied to planetary formation or conditions that no longer exist. This idea remained vague by necessity. Without comparable examples, it could not be expanded further. Others explored the concept of artificial origin without assigning agency. Artificial does not imply human. It implies intentional arrangement of material. Under this framework, the structure could be the result of unknown processes that produce ordered systems, rare, but not impossible in principle. However, no known natural mechanism produces metallic order at this scale. Importantly, the investigation avoided attributing purpose. The signal emitted by the structure did not resemble communication. It lacked modulation, variation, or response. It behaved more like a system maintaining itself than one attempting interaction. This made it difficult to assign motive, even hypothetically. What frustrated researchers most was the absence of escalation. The structure did not change as it was studied. It did not react to observation. It did not degrade or intensify. It simply remained. In science, some questions persist not because they are mysterious, but because the tools required to answer them do not yet exist. The Antarctic structure falls into this category. Physical access is impossible. Sampling cannot be performed. All conclusions must be drawn indirectly. As a result, the investigation reached a boundary. Beyond it lay speculation unsupported by evidence. On one side stood well-documented anomalies. On the other, imagination. Researchers stopped short of crossing that line. What remained was an object that did not fit Earth's known history, did not behave like natural matter, and could not be explained by existing models. Its origin was not identified, not because it was hidden deliberately, but because the data refused to point in any familiar direction. Sometimes, the most unsettling conclusion is not that an answer exists, but that none can yet be reached. As the investigation reached its analytical limits, attention shifted from origin to consequence. What would it mean if the structure beneath the Antarctic ice were confirmed, publicly, unequivocally, as something beyond known natural processes? The question extended far beyond geology or physics. It touched nearly every domain of human understanding. Scientifically, such confirmation would force a reassessment of foundational assumptions. Earth science relies on the principle that large-scale structures can be traced to identifiable processes. If an exception exists, one that cannot be explained by known mechanisms, then existing models are incomplete. This would not invalidate science, but it would expose its boundaries. New frameworks would be required, not to replace what is known, but to accommodate what does not fit. Politically, the implications would be immediate and complex. Antarctica is governed by international treaty, designated for peaceful research and environmental protection. Any discovery of global significance beneath its ice would raise questions of access, authority, and control. Who decides what can be excavated? Who owns the data? And who determines how much the public should know? Historically, discoveries that challenge consensus often meet resistance, not because they are false, but because they destabilize established narratives. Governments and institutions tend to move cautiously when confronted with uncertainty that could provoke fear, speculation, or geopolitical tension. In this context, silence can appear safer than disclosure. There is also the issue of interpretation. Confirmation does not guarantee understanding. A structure can be acknowledged without being explained. Data can be released without consensus. In such situations, public imagination fills the gaps left by science. Speculation accelerates faster than evidence. The absence of clear answers becomes fertile ground for misinformation. Psychologically, the impact would be subtle but profound. Humanity defines itself partly through origin stories: where we come from, how we arrived here, what has shaped our planet. An object beneath Antarctica that predates known history and defies classification would challenge the assumption that Earth's past is fully charted. It would suggest that something significant occurred outside the margins of recorded time. Importantly, this does not imply intent, intelligence, or threat. The structure has shown no signs of interaction. It emits no message. It does not respond. It exists. And that existence alone is what unsettles established frameworks. Presence without explanation is more disruptive than confrontation. Some researchers argue that withholding conclusions is responsible, that premature interpretation could damage credibility and stall legitimate inquiry. Others counter that transparency is essential, that uncertainty should be shared rather than concealed. Between these positions lies a familiar tension, the balance between caution and curiosity. What is certain is that confirmation would not bring closure. It would not answer every question. Instead, it would formalize uncertainty, transforming a fringe anomaly into a recognized scientific problem. Human history is marked by moments when discovery outpaced understanding. Each time, the initial shock gave way to new disciplines, new methods, and new questions. The Antarctic structure, if confirmed, would belong to this lineage, not as a revelation, but as a disruption. The signal beneath the ice does not demand attention, but confirmation would make ignoring it impossible. At the end of every investigation lies a moment where evidence stops accumulating, but questions do not. The signal beneath the ice of Antarctica has reached that point. It has been measured, mapped, and analyzed within the limits of current technology. Its existence is supported by data. Its behavior is consistent. Its location is fixed. And yet, its meaning remains unresolved. What lies beneath the ice does not announce itself. It does not escalate. It does not respond to observation. It exists in a state of passive persistence, unaffected by time, pressure, or attention. In a world where most anomalies fade under scrutiny, this one does not. It simply continues. The temptation to assign explanation is strong. History shows that when faced with uncertainty, humans rush to fill gaps with certainty, sometimes prematurely. But the most responsible conclusion in this case is restraint. The structure beneath Antarctica has not been identified as a threat, a message, or a relic of known history. It has only been identified as real, anomalous, and incompatible with existing models. This distinction matters. Mystery does not require belief. It requires acknowledgement. The data does not ask us to abandon science, but to recognize where its current reach ends. Every major advancement in understanding began at such edges, places where observation outpaced explanation. The Antarctic ice has preserved this anomaly not as a warning, but as a record. It has isolated it from erosion, contamination, and interference. Whether by coincidence or necessity, the ice has functioned as a seal, maintaining something across spans of time that exceed human context. Perhaps future technology will allow direct access. Perhaps new models will emerge that render the anomaly ordinary. Or perhaps it will remain what it is now, a reminder that Earth still holds chapters of its history that are unread. What makes this discovery significant is not speculation about origin, but the discipline exercised in its study. Scientists did not claim what they could not prove. They documented what they observed and stopped where evidence stopped. In an age of constant information, that restraint is rare. The signal beneath the ice does not tell us who we are. It tells us that we do not yet know everything about where we stand. If this exploration challenged your assumptions and sparked curiosity, consider subscribing to the channel. Each episode examines mysteries grounded in real data, where certainty ends and questions begin. In the next episode, we shift from frozen silence to human perception itself, investigating shadow people. Figures reported across cultures and time, raising the question of whether they are psychological phenomena, neurological misfires, or something science has yet to fully explain. Subscribe, and continue exploring the unanswered questions that still exist at the edge of understanding.